Lanka, currently operating in, thank you, Dr. Logi, currently operating in United States of America and UAE in Dubai. Well, ASCII Corporation has developed a learning platform, and together with ETIT, we have developed this program called AIeye. AIeye, it's artificial intelligence fundamentals and applications. So we have developed this program for uh, school students, university students, and professionals, those who want to learn the basics of artificial intelligence and the applications. So for age 15 and above, any person can join this program, because we take you through from the fundamentals to the applications, and it is very practical oriented program. And today's program is a test program that we do using the AIeye program. So AIeye program, in fact, it is an 18 session program. So we cannot do all the 18 sessions during this test. So we have concised that into 5 sessions, and we cannot cover all the things, but we cover some important aspects of AI during this 5 sessions. So I would like to request all of you, if you can switch on your cameras, it is better. I would like to see your beautiful faces. And also feel free to ask any questions from our resource persons. And today we have some members of ASCII Corporation in Sri Lanka join from Sri Lanka for the program, especially Dr. Logeeshan, Engineer Chandra, Irugal Bandara, Engineer Sasmita, and Engineer Nazim. So I believe there are 4, yes. So they are part of ASCII Corporation. In fact, they are from the same university, electrical engineers, and they have started this company during their university years. And today, they are a company that recognized in the industry that they are specialized in artificial intelligence solution developments. Well, today's session will be conducted by Dr. Logeeshan Velamanikam. So Dr. Logeeshan currently working as a senior lecturer at University of Moratuwa, and he is a highly accomplished scholar, a practitioner in the field of artificial intelligence and electrical engineering. He has won a gold medal for his PhD thesis at North Dakota State University, USA. Currently, he has 3 patents and 1 invention disclosure for his research work. He has published 45 peer-reviewed articles within a very short span of time, and one of his research is early detection of pancreatic cancers using artificial intelligence. He's an advisor to the Cancer Score organization in USA, and not only in his academics and his industry experience, but he also a musician, a cricketer, and a fantastic human being. So Dr. Logeeshan is just 32 years. So please welcome to conduct today's session, Dr. Logeeshan.
Thank you, Vera, for the wonderful introduction. So let me take over from this point. Let me share my screen first of all, right? I hope you all can see my screen. Okay, so I will send the link first to the chat, this Zoom chat. So I would like to request everyone to click this link. So before we start the lectures, today's session, I would like to walk you through these platform, the AIeye platform and the features, because this is the platform that we are going to use to deliver this course. So once you click this link, you will be routed to the AIeye platform. So if you could click it while looking at my screen, you will be going to this link. So there, I would like to invite you all to click this join button, join now button, to join this platform. So once you click it, it'll go to another link. So where you have to enter the username, passwords, email address, and all the other details, required detail to create your account. So I will wait for 5 minutes for you to create your account. So once it's done, then we can directly jump into the platform. First 10 to 15 minutes, I will utilize that time to walk you through the platform. What are the features that we have? How you can utilize this platform while you are learning. So after that, we will jump directly into the AI part. Okay, so I will wait for 5 minutes for you to create this login. So once you done with creation of the link, that platform login, uh, could you please put a thumbs up or hands up in the chat? Then I'll be able to know like how many people have totally done that one. So far I got 4 thumbs up. 1, 2, 3, 4, 5. Yes, 6.
If you have any problem of creating your user, you can open your mic and talk to us.
Yep. We got close to 12 thumbs ups. Yeah, 13 thing. Right, we will wait for another couple of minutes. Then we will right away jump into the platform. All right, so I hope most of you have got your login details and you have signed up to the platform. So let me start the walkthrough. So I'll go and join using my username and password over here. So once you log in, you will be routed to the home website. Okay, so here you can see we have two course modules already have allocated in the platform. So the AI Summerfest 2023 was conducted during last June, right? During the summertime in Dubai. It's a 4-day program. So we have successfully concluded that one. And this is the one, Artificial Intelligence Fundamentals and Application is the one that we are going to launch in the upcoming year in Dubai. So this is the test run as Para said. So you are going to see and experience the platform as a first people, right? Other than ASCII people, you people are going to be the first. All right. So once you come down here in your right-hand side, you might have noticed a chatbot. So once you click it, yes, yeah. Once you click it, you can see there are two options. One is a message and other one is a microphone option. So once you click the message option, so you will get a login detail again. So you have to enter details in the platform. This is only for the first time login, because when you are coming for the second time, third time, it has all the details about you. So you can directly go and log into this chatbot. So basically this AI teaching assistant bot is created to answer any sort of questions related to the subjects that you are going to cover in this module. Artificial intelligence and fundamentals applications. So it'll be able to answer all the questions. So unlike the answers that you get from ChatGPT, these answers are customized in such a way where the beginners can understand from the basics. So we have generated the backend knowledge base and we have integrated to this chatbot. So it is going to pull out the answer and it is going to provide you regarding any doubts on the subjects, codes, or it can be related to AI or it can be related to Python. So any sort of doubts, so you can ask from this AI assistant. So once you log in, so you'll be able to get a welcome message like that. Hello, Logeeshan. So my name is Wishes and welcome back. I'm your teaching assistant robot. Would you please click on the sun and select the week number? So here, once you go here we have 18-week sessions uploaded over here. So today we are going to cover the week 1. So if you have any questions related to week 1, you can just click week 1. Then whatever the question that you are going to ask, the chatbot, the AI teaching bot will be able to provide an answer and help you to understand more. So here you can say what is maybe error function. So you will learn that thing today to just show the platform functionality. So I'm going showing. So it's pull out the answer. The error function, also known as the logs function, is mathematical function that measures the difference between the predicted output of a neural network. So these things, answers are provided based on the information that we have provided to this bot, to this AI bot. So it structured the answer in such a way where the beginners can easily understand. At the same time, you can verbally like click the mic and you can ask questions. It'll be able to get all those information over here. So once you have done talking, click this one, then it will be able to post it to the platform. Right? So that is one. Yeah.
Dr.
Yep.
Logeeshan, can you demonstrate one? Can you answer a question that, well, let's see how it is answering?
All right, sure. Let me get it. All right. So here, once you come here, so I can ask, what is meant by the error function? Here you can unmute yourself and you can get the answer through sound also. Let me share the sound. So I hope you can hear.
The error function, also known as the loss function, is a mathematical function that measures the difference between the predicted output of a neural network and the actual output.
So you can have a chat in voice basis also. Similarly, you can ask any question related to the chatbot. So we have another option over here. So the mic option. So once you click that mic option, it will route to another platform which having an avatar. So basically, this platform is specially designed for the kids from 15 years to 20 and more. But even the 13 years kids can get the knowledge about AI through this platform. So as you can do the same chat the similar way that you have done with the chat interface, here you can click the mic and ask the questions related to the platform or related to the courses that you are going to cover. What is meant by error function? So you can test these features out after I completed the session. So leisurely you can.
The error function, also known as the loss function, is a mathematical function that measures the difference between the predicted output of a neural network and the actual output. It quantifies the error or loss of the model's predictions. In the context of character recognition using deep learning, we use the categorical cross-entropy.
Yes. So like that, you will be able to understand. You can get the answers. You can clear your doubts. And those answers will be 100% correct because we have provided the context. Unlike ChatGPT, some answers you cannot trust. It's just coming from the generative AI. But this you can completely trust because the knowledge base is provided by us. All right. So just join the meeting few minutes back. Can I get the link to the login platform? Yes, sure. So I'm going to just add it over here. You can log in. All right. So like that, we have all those stuff added. So once you go to the courses, so you will be having two courses, AI Summerfest and Artificial Intelligence Fundamental Application. So this is the one that we are going to test today. So once you log in, here you will have 18 weeks of program, right? 18 weeks of program, which you can see over here. So the first day, today we are going to cover the week 1, the artificial brain. So once you click it out, so it will ask, okay, self-enrollment, student, no enrollment key required. So since this is the first time that we are allowing the outsiders to come and test the platform, so we open this platform for everyone to enroll it for free. Otherwise, if it's a paid service, once you make the payment through the platform, then the enrollment key will be sent to you. So that will be the feature added. This time it's completely free, so no enrollment key is required. So you can just click enroll me and you can directly get into the platform, the course for today. All right. So, okay. All right. So you can see all those stuff over here, AI fundamentals. And lecture 1 video is added over here. So this platform have two options. One is live recording. We are going to teach in live sessions. So the students can join in live and ask questions and interactively participate in the lecture. Or else we have created a video, which is an animation video, to give the same lesson for a kid to make more interesting way. So there the avatars comes in, then the avatars talks. So the student will be able to learn through this video platform as well. All right. So today I'm going to do it live. So you can check those video later on after this lecture session. So I would like to invite everyone to ask questions in the middle. If you have any questions in the middle, raise your hand or just interrupt me. Then I'll be able to stop at the middle and I'll be able to clarify the doubts. All right. Shall we start, Pera, the lecture session? Do you have any question in the platform?
Yeah, in fact, to all the viewers, that the platform, as Dr. Logi said, it is a testing phase, and there are certain changes we are doing it. So very soon you will see a different outlook in this platform. So at the end of this session, we would like to have your feedback, your experience, what you gain through the platform, and that will help us to do the development a better way, user friendly. And so we value that your feedback at the end of the program. Go ahead, Dr. Dogi, you can go to the presentation and do it.
All right. Thank you, Bala. I hope you all can see my slides.
Yes.
All right. Okay. Hello, everyone. Welcome to the week 1 of 18-week Artificial Intelligence Fundamentals and Applications program with AIeye. In this program, we will understand what artificial intelligence is and learn how to develop AI-based solution to various problems. Before moving on to artificial intelligence, we will understand the artificial brain, how it can be trained and how it learns. Here you see biological neurons. The human brain has approximately 83 billion biological neurons. Neurons are interconnected with each other. They process and share information. You can see the neurons in the blue background. So those are connected with each other. So those are the main particle in the brain which makes the brain function. So when you learn something new, the neurons makes the huge contribution to memorize, make decision, and play a crucial role in daily life. So that is the biological neurons. Information to the brain, it comes from the 5 senses that the human have. Because based on those information only, our brain is going to decide what to do. So if you are seeing a dog on the road, the brain receives the information through the 5 senses, and it processes the information in the brain and decides whether should I run or should I stay and fight back the dog, right? So what are those 5 senses of human? So we have eyes for vision, ears for hearing or audition, nose for smelling aromas, tongue for taste. At the same time, finally, we have skin for haptics or touch, as well as it can feel the temperature or humidity, etc. So these information from these 5 senses are the inputs to the brain. So when you see a dog, you hear the dog barking, and your eye sees the dog is there on the road, then this information goes as an input to your brain. Then the brain processes that information and makes decision and recommends actions. These decisions are the outputs from the brain. So the brain tells you, fight back or just run away or take a stone and throw on the dog. So all these decisions are the output from the brain. For example, you go to school in the morning, you see your teacher. Your brain receives an image of your teacher. This image is the input information to the brain. The brain processes the image information and recognize your teacher and say, good morning, teacher. So this decision to say good morning to your teacher is the output from the brain. So the brain neurons are the information processing element of the brain. It receives the information from 5 senses that we have, and it processes the information and it provides the output. So the neurons in the brain makes that happen. So the neurons are the information processing elements of the brain. Now let's take a close look at the architecture of the biological neuron. It's a graphical representation of a biological neuron. So the first part is dendrites. Dendrites receives the information as an input from the senses directly or from the other neurons. So it can be directly from the senses that we have, or from one neuron, it can receive the information. So it can directly receive the information from the senses or from other neurons. The second important part of the neuron is nucleus. Nucleus is the control center of the neuron, which processes the input information that came through the dendrites and produces an output. So that is the key element in the biological neuron. Then the other important part is axon. The axon communicates the output to the other neurons. So that means the nucleus makes the decision, which the information gathered from the dendrites, then it sends that information through the axons to the other neurons. So the last important part of the neurons that we are interested in as an engineer, AI engineer, is synapses. Synapses represents the connection strength between the neurons. So this synapses makes the connection between the other neurons, right? So I will show a video, so you'll be able to understand more after looking at the video. So when you learn something new, these connection strengths can get stronger and stronger, or it can become weaker and weaker. So it's a bit like when you practice a game. So you go to play badminton and you practice at the first time, you are not that good. So second day, you go for practice, somewhat good. Third day, fourth day, after a month of practice, you will be able to play the badminton really well. That is because of the connections that these synapses makes with the other neurons. So I'm going to summarize again. We have dendrites. Dendrites receive the input information from the senses directly or from other neurons. And the nucleus, that is the important section of the nucleus, okay? So this is the control center of the neuron, which processes the information that received from the sensors or other neurons through the dendrites, and it produces an output. So the axon communicates that output to the other neurons, where the synapses represent the connection strength between the neurons. When you learn something new, this connection strength can get stronger or weaker. A network of large number of neurons is called
Dr. Logie, I have a question. Sorry for disturbing you. Why it is important for us to learn human brain, how the neurons work, to understand AI?
Yes, I was waiting for this question actually. Thanks, Pera, for asking. So basically, if you see, all the human inventions so far are inspired by the nature. So the human look at the bird, birds are flying. So he have tried several ways to make a machine which can fly like a bird. But at the initial stage, the human failed. But with the practice and failure and trial and error, finally, now we have aeroplanes. So those came from inspiration of birds, right? Similarly, the solar panels. Right now, everyone is going through the green energy. Everyone would like to have a solar panel in their home rooftop. So how the solar panel works, where the inspiration came from? Who can look at the tree? Tree survives by producing the energy from the sunlight. So then he thinks, okay, like if the tree can produce in such a way, so why I can't? Then he studied the nature of the leaves. Then he created the solar panel. So right now we have solar panels. Similarly, the neural network, the AI, is inspired by the brain neurons. So understanding the brain neuron architecture is very important to understand the AI neurons. Did I answer your question, Farah?
Yeah. Yes, you answered. So others also, I encourage them, if they have any questions, please feel free to ask.
All right. So now we will move on. So a network of large number of neurons is called a neural network. On the left hand of left image in your slide shows the neural network. So there are multiple 83 billion neurons in your brain. So those are interconnected and interwired kind of stuff. So those are known as neural network or network of neurons. Basically, different parts of the brain have different sets of neural networks. These neural networks are responsible for different functions. For example, the neural network in the optical lobe of the brain are specialized in processing visual information. It is these neural networks that help you to identify your teacher, which receives the information through the eyes and process the information in the optical lobe, and it produces the output. So the neural networks in the frontal lobe are specialized in planning actions and making decisions. So it is these neural networks that decided to say good morning to your teacher. There are many more parts inside the brain, right? So now let's look at an animated video to better understand the neurons, that means the biological neurons operations.
Neurons communicate with each other, relaying messages throughout your body and powering all of your thoughts and actions. Neurons talk to each other using both electrical and chemical signals. Messages start as electrical signals traveling rapidly down a neuron. These signals are called action potentials. When they reach the gap between two neurons, the messages need some help to get across. The information is transformed from an action potential into a chemical message, which crosses the gap called a synapse. The release of those chemical messengers can trigger an action potential in the neuron on the other side of the synapse, conveying the message onward. Or it can quiet the message. This happens over and over and over. And with repeated activity, the synapse gets stronger, so the next message is more likely to get through. That way, neurons learn to pass on important messages and ignore the rest. This is how our brains learn and adapt to an ever-changing world.
Right? I hope that video helps. Okay. So now I'm going to ask a question to all of you. So when do you think that AI talk have been initiated? So when do you think the AI started its life? Any guesses? Is it recently after the ChatGPT release, 2018? Or after the BERT model release by Google, 2012? Any guesses? You can type or you can unmute and you can say. Nobody want to guess? Okay, fine. So let me say that. So the people started to think about how to make machines intelligent, not in the recent past, but it was in 1950s. The artificial intelligence was a major topic at the Dartmouth conference in 1956. So here you can see the commemorative plaque marking the 50th anniversary of the Dartmouth conference, right? So there they have particularly mentioned, so founding of artificial intelligence as a research discipline, like they had in commemoration of the project's 50th anniversary, July 13, 2006. It was released because in this building, it was 1956, it was initiated, right? So that means the talk of AI is not recently. It's initiated in 1956. They have to make the machines think like human. So if they want to make the machine think like human, they have to study how the human thinks. So that's what happened. They study the neurons architectures. Finally, we have the AI as a hot topic right now. Okay. So an intelligent machine needs an artificial brain. As a result, over the years, mathematical models of neurons and neural networks were developed so that an artificial brain can be implemented on a digital computer. Therefore, an artificial brain is a mathematical model of neural networks implemented in digital computer. So in these slides, so in 1943, a mathematical model of neuron was developed. Then after that, 1956, the talk was initiated as artificial intelligence. Then 1958, single layer perception. 1986, backpropagation. 89, convolutional neural network. 90s, recurrent, and 2006, deep learning. So through the way, we got a lot of improvement. Finally, we are in an era where the AI is going to take over many work done manually right now. All right, so let's dive in deeper to understand the mathematical models of the AI neurons. So now let's explore and compare the contrast between a biological neuron and a mathematical model of neuron. Here we see a biological neuron that receives information or inputs from 3 other neurons. Now let's take a look at the artificial neuron or mathematical model. X1, X2, X3 represents the inputs receiving from the other neurons. These are simply called the inputs. W1, W2, and W3 represent the connection strength between the neuron and the other neurons. These are called the connection weights. Y represents the output of the neuron. F is the function that describes the relationship between the inputs and outputs and the connecting weights. The function F is called the activation function. All right. So is there any connection with the biological neuron and the mathematical neuron? Yes. The biological neuron receives information from other neurons through dendrites. All right. So here we are getting information as X1, X2, X3 that acts as dendrites of the mathematical neuron. So then to communicate with each other, the biological neurons use the synapses action potential. So that strength of the potential varies based on the thing that you are doing. So here, the connection weights W1, W2, W3 represents the strength that is equivalent to the synapses of the biological neuron. The output is Y, which is equivalent to the axon in the biological neuron. The F, that is equivalent to the nucleus in the biological neuron. So which is the core part, which is going to take the decision output and it's going to send it through the axon as Y. All right. So now this example shows how to use the activation function to determine the output using the inputs and the weight. For simplicity, here we consider a linear activation function. In the function, the B is a constant, which is called as the bias. So if you see, basically, the linear activation function, what it does is, the X1 is multiplied by W1 and addition. X2 multiplies by the corresponding connection weight, addition, and X3 input multiplies by the W3 connection weight, and an addition, and the bias is added over here, which is not shown over here in the mathematical neuron. So when we are going into details in upcoming slides, we will be able to understand what is this bias. So basically, in a short way, if I want to demonstrate, bias in activation functions are like giving a robot a little nudge to start doing specific tasks. So helping it learn and make decisions more effectively. So the biases are used to make sure the output from this activation function is strength enough to fire or produce the output through the Y. So you keep that in mind. Bias is something which is added to the output from the activation function. All right. So it's very easy. If it's a linear activation function, only the inputs are going to be multiplied and added together. If there is a bias, then it's going to be also added together. All right. So now I would invite everyone to try a small example. So since we have limited time, so I will quickly walk you through the example. Then I will give you a few minutes for you to try. Then we will go to the answer and you can check it out. So now, this is the neural network. Mathematical neuron is given. X1, X2, X3 are the inputs given to that neuron from the other neurons or sensors directly. W1, W2, W3 are the weights. And the question is, what is the output Y? Right? The values are given. X1 is equal to 0.2, X2 is equal to 0.1, and X3 is equal to 0.3. And the weights are 0.5, minus 0.2, and 0.8 are given over here. So I will give you 2 minutes to compute that. Later on, we will walk you through the answer and we will go to the next chapter. If you have any questions, you can raise your hand or you can add it to the chat. So I'll be able to answer those questions. So the equation of Y is given, that's the activation function, is just multiplication and addition.
One, three, two.
Okay, yeah, I got an answer, 0.32. So I hope everyone got the answer. Let's move on to the next slide. All right. So it's just multiplication and addition. So the 0.5 multiplied by 0.2 minus 0.2 multiplied by 0.1 and 0.8 multiplied by 0.3 is going to give you an output. Y is equal to 0.32. So that's how the mathematical neurons produces the output. So this output will be provided to another neuron. So we are coming up to that point in the next slide. So now we have seen a single neuron, mathematically modeled single neuron, which has all the features of the biological neuron. But the biological neurons are interconnected to make decisions and provide the output. So how this mathematical neuron is going to be get interconnected? So A network of artificial neuron is called an artificial neural network. So you might have heard this word artificial neural network, or in short format, it can be ANN. A neural network can have many inputs and many outputs. So in the biological neuron, we had multiple inputs, but only one output. But in the neural network, it can be multiple inputs and multiple outputs. Input layer neurons receive information or inputs from outside. It can be from the sensors or from the other neural networks. Output layer neurons produces the final output. So in between the input layer and the output layer, there are one or many other layers of neurons. They are called hidden layers. They are called hidden layers. The connection strength of the different layers are represented by connection weights. Large neural network has large number of weights. So we have seen a single neuron and we calculated the output. Now we are going to do an example to calculate a simple neural network output. So it has 3 inputs and x1, x2, x3, and it's connected to one single hidden layer, that is y1, y2, y3, and the output 2 neurons. So there are 3 layers. One is input layer and one is hidden layer. Only one hidden layer. There can be multiple hidden layers based on the complexity. For simple computation, we are only having one hidden layer, and there are 2 output layer neurons. So where the x1 is given as 10, x2 is given as 5, and x3 is given as 2, and the corresponding connection weights are indicated in the line, in the arrows, connection arrows. Okay. So now the question is,
Dr.
Yeah.
Logi,
Yeah.
can you elaborate on this hidden layer, and how do you can you relate that to the human brain neural network?
Yes. Yes, definitely. So as I mentioned earlier, so when you receive the information from the sensors to a neuron, so we have 83 billion neurons. If you want to have one neuron to make the decision, only we need to have 5 neurons because we have 5 sensors. But not like that. The brain works in a different way. So these 83 billion neurons are interconnected with each other. So the input neuron is the neuron that is directly getting the information from the sensors, right? And the hidden layers, there will be multiple hidden layers, 1, 2, 3, 4, like that. So like it can be thousands, like even more than 10,000 millions, right? Because we have 83 billions. So those are interconnected. So the input layer receives the information from the sensors, and the output layer of the neuron produces the output directly to the actuator. So if I'm talking, it's from the output layer neuron produce output. It generated some actuator stuff. So the hidden layers means those hidden layers are used to make the decision in a particular way. For example, if you are learning something, initially, let's say there are a couple of hidden layers. So you get the input layers and it connect to the hidden layers. So the connection strength between these input layer and the hidden layer will become weak. At the beginning, it might be weak. So then if it's a complex task, okay, learning a badminton, as I told earlier. So there may be another neuron over here, which connects to that hidden layer. So this output going to make a connection with this thing. For example, you are seeing the badminton shuttle come to you. So immediately you have to make a decision to smash it or drop it, or you are going to like leave it. So these decisions are the output. So to make that decision, the hidden neuron helps you. So in the go, like on the go with other sessions, you will be able to understand more and more about the hidden layer neurons and how the weights are changes to take the decision output. Did I answer your question, Pera? If you
Yeah.
didn't understand,
Dr. Logi? Yep.
yeah.
Yeah. So which means if it's a complex decisions, the more hidden neurons get activated in order to give the answer.
100%, 100%.
Okay.
Based on the task, more hidden layers get activated. That's true. Similarly, in the mathematical neurons also, it will be the same. So for doing a small task, couple of hidden layers are enough. But if it's a really complex task, then you have to stack the layers to make the correct decision. All right. So this is a little bit complex addition and getting the output. So basically the x1 will be multiplied by 0.5, 0.3 and 0.4, like 0.5, and x2 into 0.4, x3 into 0.3 to get the y1. So similarly the x1 into 0.3, x2 into minus 0.4 and x3 into 0.5 to get the y2, and x3 into 0.8 minus x2, 2 into x2 and 0.4 into x1 will give you the y3. Then that output is going to be multiplied by these connection weights to take the O1 and O2. So since it's a tedious task, I will just show you the answer. So here, the y1, that is the formula for calculating the activation function. So W1 into X1, W2 into X2, W3 into X3. So then if you want to calculate the Y1, 0.5 into 10, 0.4 into 5, and minus 0.3 into 2. So if you calculate, the Y1 is equal to 6.4. Then similarly, you can calculate the Y2 and the Y3, so which are going to be equivalent to 2 and 4.6. So then these activation produce outputs, the Y1, Y2, Y3 are going to be the input to the output neuron. So now the 6.4 should be multiplied by 0.1 and 2 should be multiplied by minus 0.3 and Y3, that is 4.6, should be multiplied by 0.2 to take the O1. In other way, Y1 should be multiplied by minus 0.2, Y2 should be multiplied by 0.2, and Y3 should be multiplied by 0.2, take the O2 output. So once you determine that one, you will be able to get the answer. The O1 is equal to 0.96 and O2 is equal to 0.04. Is that clear? Yes, there is a question in the chat board. So can we simply say hidden layers are the options we interpret in our minds to use to make final decisions? So the hidden layers are like, it's 83 billion neurons are interconnected, right? So based on the training that you had earlier in your past history, the biological neurons are interconnected. So let's take a simple example. So if you remember as a child, so a parent is teaching a child, showing an apple. Okay, this is an apple. What is this? This is an apple. Then does the kid, next day you go and ask, what is this showing an apple? Do you think the kid will be able to answer? Definitely not. Because only one time that kid has seen the apple. So the neurons are trying to memorize that architecture by these interconnection of hidden layers, but it's not strong enough. The synapse strength is not at all enough. So now the kid cannot remember that. Like kid means I'm telling about 1 year, 1.5 years old kid. Maybe the parent teaches the kid for the second day. What is this? This is an apple. So maybe the third day again he is teaching, fourth day teaching, again and again and again teaching. Even after a while, like of teaching apple, maybe let's say, or 1 week, when the kid go to the supermarket, when it sees the apple from far away even, it will be able to identify that is an apple, right? Because the neurons are interconnected, those synapses weights are changed in such a way to make the memory of the apple, right? So if you want to train a complex task, so you have to have multiple neurons engaged together to make the final decision. If it's a small task, couple of neuron firings are enough. If it's a tedious task and you are solving a lot of mathematical problems, then you have to have a lot of connection of biological neuron interconnection. Did I answer your question, Jude? Yes. All right. Okay. So I hope that is clear. Now slowly we will move into the next section. So the concept of training and learning. What do you mean by training? So just before I have explained using an apple example, a father is teaching a kid, showing an apple and say this is an apple. Your brain learns. So let's try to understand using a different example, because apple is a small one. You might not be able to like connect it directly. But all of us are in like, let's say 18, 19 years old, 15. So you might be going to the driving school. So let's take how you learn to drive a car. So how your brain neurons are helping you to drive the car, right? So that is called as training. So what is a training? Think about going to a driving school to learn how to drive a car. In driving a car, what you see on the roads are the inputs to your brain, right? The car coming in front of you, the passengers are like pedestrians are walking on the street, there is a bike parked on the side roadway. So those are the input information that's gathered through your eyes and it's going to the brain neurons. So those are the input to your brain. Your driving actions such as steering, braking, and accelerating are the outputs from the brain, because you are going to drive the car. You observe the environmental things through your eyes and you brain process the information and it's put the outputs. Those outputs are the acceleration, steering, and braking. In the driving school, you get a trainer or driving instructor to train you how to drive actually, right? Actually, your brain is trained how to drive in the driving school. So we can explain this whole training process in step by step as follows. So based on what you see or the inputs, you generate driving action that is known as the output, that is braking, steering, and accelerating. Your trainer observes your driving actions or the outputs that you produce from the brain through your legs and hands, give you step-by-step instructions, how to correct or how to improve those driving actions. Say like, slow down, so you have to turn a little bit faster, so you have to hold the steering a little bit tighter, press the brake smooth way. So those are the instructions that you get while your brain is processing these information. Actually, your trainer trains your brain and your brain learns how to drive safely and efficiently. The inputs and the trainer recommended outputs are the training information or training data your brain uses in this training process. Similarly, training an artificial neural network requires training data. After the training period is over, you will take the driving license test. Also, in the artificial intelligence, the trained network is tested using the test data to test whether the training is successful or not. Right? So this process of learning is known as supervised learning, because you are learning you are getting the information through your eyes and you are generating the output from the brain, but you are supervised by the instructor who is sitting next to you. By observing your output and the errors that you are making while driving, he is trying to make the correction. Then the brain understands that and it makes to try to learn from that supervision. So that is known as supervised learning, right? Keep that word in mind, supervised learning. So there is a supervision happening while you are learning. Now let's go to another type of learning, which is known as reinforcement learning. Is another method that is heavily used in modern day artificial intelligence, gaming, especially the kids who play the games. So there, if it's an AI-based game, definitely this reinforcement learning is used over there. So now imagine we'll take the same example as the driving school. So now you imagine you are in a driving school again, but this time your driving instructor isn't giving you step-by-step instruction. Every time you make a turn or accelerate or press the brake, your instructor gives you a reward if you did something right, or he gives you a penalty by showing a red flag or something in the animation as it is if you make a mistake. You use this experience to produce actions that lead to higher rewards and avoid the actions that result in penalties. So when you drive, the instructor tells you rewards or penalty. So based on that, you always want to get much more rewards. So you change your action based on that feedback of the instructor. That is kind of told as reinforcement learning. So in the artificial intelligence, reinforcement learning is happening in the similar way to gain more rewards and reduces the penalty. The neural network produces actions and receives rewards or penalties based on those actions. Over time, it learns to take actions that lead to higher rewards and avoid actions that result in penalties. All right? So that is known as reinforcement learning. Learning can also take place in unsupervised way or even without a trainer. So earlier there is a trainer who is step-by-step instruction he is giving. Second thing, he is not there next to your seat, but he is giving some penalties and rewards. Now there is no instructors. So now let's say you are exploring a new area with your car. Because during the driving test, learning driving, you know what you do. You take the car more or less through the same path. So it knows the brain have registered in your, the map is registered in your brain. Okay, there is a junction, there is a stop sign, so I have to stop. So all those things are registered. More or less, you are going to take the same route from the driving school while learning. But now, let's say you are exploring a completely new area with your car. But this time, there is no trainer because you got the driving license. You are not getting any guidance. As you explore, you start to notice patterns in the traffic, roads, shapes, and the stop signs, and the way the pedestrian moves, all are new. So you might notice that certain types of traffic tend to be in specific areas, or that some roads are busier than the others. Here you are learning about the world without anyone telling you what is what. You are observing and you are trying to learn by yourself. This process of discovering patterns and grouping similar things together is similar to how unsupervised learning works in artificial intelligence. So the neural network looks at a lot of data and tries to find patterns or similarities without any explicit instructions. So now we have learned 3 ways of training the neural networks.
Yeah, Dr. Logi, there is a question in the chat box, if you can into that.
Is supervised learning a subcomponent of the overall concept of machine learning? Kind of, yeah, we can say that as well. Yes. So you have to have label data and everything for the machine learning. So we can say a supervised learning. So when it's come to deep learning, we have reinforcement as well as we have these unsupervised learning. So the machine learning, yeah, you are right. Right. So as a summary, up to now, we have learned how a biological neuron look like, how a mathematical neuron look like, how the biological neuron network function, and how a mathematical neural network functions, and how that biological neurons versus the mathematical neurons are trained. There are three ways: supervised learning, unsupervised learning, and reinforcement learning, right? So the learning and the training can happen in these three ways. Okay, keep that in mind: supervised learning, reinforcement learning, and unsupervised learning. All right. So now let's move into the training process. So now let's discuss the supervised training process in an artificial neural network. So the same kind of neural network that we have used earlier, one is having two inputs and one hidden layer and one output layer. And there are two neurons in the input layer, two neurons are in the output layer, and there are 4 neurons in the hidden layer. So the supervised training requires input training data as well as the output training data or the desired outputs, right? If you are input an apple image, that apple image or the apple should have the label as apple. Like this is an apple, right? So if you are input an image to train the neural network an orange, then it should have the label as orange. Okay, so that's why the data is needed. So imagine example, you want to characterize certain stuff, apple, orange, banana, and strawberries. So you are going to train these networks. So you have to have all those images labeled as banana, apple as apple. So those are the training data that we require for the supervised learning. As the father taught, this is an apple to the kid. All right. So in here, the input layer of the neural network. Give me a second, there should be an animation. All right. So the input layer of the neural network receives input training data. For each input training data set, the neural network produces an output. Let's call this output as an actual output. Okay. So this output is compared with the desired output from the training data. For example, for the first iteration, we are getting 0.64, and second, it's improved to 0.82. Then it's improved to 1. So like you can see the output is changing, at the same time the weights also changed. So for each input training data set, the neural network produces an output. Let's call this output as an actual output. With the output from the training data. So adapting weight, and it's compare, you show an apple image, then the neural network produces an output as orange, right? That's a wrong output. Then it compares, okay, whether the output is put label. No, then it comes back and say, adjust the weights because I'm getting a wrong output, right? Then it's train backwards, adjusting the weights and come back. Then when you add an orange image, detects as an apple, then it's compare, the input is an orange, but that I have detected in the output is an apple. So again wrong. Okay, I need to change the weights. Still, I'm not correct. So it's come back and the weights are changed. So like that, keep on training. It will keep on training. The weights will be adjusted at a certain point. When you put the apple image, the neural network will be able to predict that image as apple. So that means apple is predicted as apple. So there means low error value. There is no mismatch. with the input and the output. So to that level, we have to bring the neural network training process. So that is called as training, supervised learning or supervised training. So the difference between the desired out and the actual output is the error. So that means minus apple is the error. So now I'm talking about the words. So there are certain ways we can, that we will dig into detail when in upcoming lectures. You see the difference between actual output and the desired output is known as the error. So connecting weights are adapted in such a way the error is minimized, right? You are keep on training, input an apple image, orange detected, error calculated, come, weight is adjusted, second image, like that. You are keep on training the neural network. We can say the error value determined is optimized or minimized, right? So this means an artificial brain learns how to produce the correct output by adapting its connecting weights. I'm going to play the animation again. So first input came, calculated outputs, error is calculated, nothing. Again, the weights are changed, it got improved. Again, calculate the weight, there's an error. Again, the thing is, weights are changed. Finally, we were able to get the output 1. So like that, the neural networks are trained. So now, let's take a look at the practical problem, right? So that can be observed or solved using a simple neural network. So we are all familiar connecting a LED bulb to a battery and making light up, because that's a very small practical, even in school days, that we have done, right? So when connected to a load such as light bulb, a battery produces a DC current. We know the Ohm's law, V is equal to I into R, right? So the value of the current depends on the load that you have connected to the battery. This means if you add different loads, the current drawn from the battery also will be different. Batteries have internal resistance. Here, there is an R indicated over here. This is the internal resistance of the battery. When there is a current battery terminal voltage drop, this is due to the internal resistance. So terminal voltage means from this point to this point, battery terminal voltage, right? The load is connected to the battery terminal, but there is an internal resistance inside the battery, right? I can ask a question to simply make you understand. We have car batteries. To start a car, we use a car 12-volt battery, right? So the car battery will be able to start the car without any problem. That is 12 voltage. Why can't you get like couple of AAA batteries or AA batteries and connect them on series and connect to the car that is also 12 voltage? Can you start a car? No. You can't start a car. Otherwise, if we can start a car, we all can have a battery pack in our car. Once the car stopped without battery, you can connect all these things together and start up the car. It cannot be done. Why? Because of the high internal resistance value inside the batteries, right? Therefore, it will not produce enough current to start the car. Therefore, we need lead acid batteries. Those are high current producing batteries that is required to start the car. So now let's delve into this example a little bit more and try to understand how the neural networks work to predict these internal resistance, because you cannot measure the internal resistance directly because it's internally there, right? So it's due to the chemical properties of the battery. So you have to do certain practical experiments to determine the internal resistance value. So let's go into that part. So here, if you look at this one, IC is the circuit current. VT is the battery terminal voltage. That means from here to here. R is the internal resistance. E is the open circuit voltage, right? Battery terminal voltage. And the open circuit voltage mean when there is no load connected, what is the voltage in between these two? And the VT can be given as, the circuit equation can be written using the Kirchhoff voltage law as VT is equal to minus into R IC plus E. E is the open circuit voltage, right? So using the Kirchhoff voltage law, we can write this equation in such a way, VT, the battery terminal voltage, is equal to minus R, that is the internal resistance, into the circuit current IC plus the open circuit voltage E. All right. So according to this equation, terminal voltage drops with increase in current. Now you know why you can't start a car by seriously connecting AAA's batteries, right? So we will study how AI can be used to determine the internal resistance of the battery experimentally. In the experiment, we vary the load to vary the circuit current. We recorded the terminal voltage at different values of the circuit current. The experimental data is shown over here in the table. This data will be used to train the neural network that we will see shortly. Take a look at the circuit equation. Here, R and E are constants because E is the open circuit voltage. There is no load connected. When you measure, if is it AAA battery is going to be giving 1.5 ampere voltage, right? The R is the internal resistance. That is also a constant one. It's not going to change. So these two are constants. Only the IC and VT are the variables for this practical. The circuit equation takes from a straight line, or which is more or less similar to the Y is equal to mx plus c equation format, right? So if you remember, this is the equation that we try to fit to a linear curve in the XY thing, right? So if we use the collected experimental data to find the equation of the straight line, we can determine the M, that is the slope. Then the internal resistance will be equal to minus R, right? So again, I am summarizing what we have done in the experiment. We vary the load to vary the circuit current, right? In the circuit, we have loads in the side, we change the load and we vary the circuit current. At the same time, we measured the voltage, terminal voltage. When there is no current passing, the voltage is 9 voltage. So that means no load connected, the terminal voltage is 9. When the current is 1 ampere, the terminal voltage is 8.7. When the current is 2 amperes with a different load, then the VT is 8.6. Like that, we have changed the load and changed the circuit current and determined the VT value. So that is a simple practical experiment that we do to calculate the resistance value, internal resistance value. So once this is done, so if we can find the linear curve, that is going to be equal to, the internal resistance is going to be equal to minus M, because here the minus is here. It takes the Y is equal to mx plus c equation format. So you can directly determine the internal resistance, R is equal to minus M. All right. So we are going to go a little bit into theoretical now. So here we will study how to get a neural network to learn the relationship between the circuit current and the terminal voltage using the experimental data, right? So in other words, to find the equation of the straight line that best fits the experimental data. This is called curve fitting or regression. Circuit current is the input to the neural network. Hence, we need only one neuron in the input layer because we have only one input. The terminal voltage is the output of the neural network. Hence, we only need one neuron in the output layer. Now, you see the table earlier. We have input current and the VT output. So, we have both the data. So, now what the neural network is going to do is, it will send the current value 0 into the input layer and it passes the information, changes the weighted, and it's going to determine the output Y, VT. So let's say for 0 input, we got actual value is 9. But let's say the neural network produced the output as 5. Then it's a wrong value. So the labeled value is 9 and the neural network is producing 5. So it calculates the error 5 minus 9. Okay, the error value is high. So then it go back and change the weights and come back and check again and again and again for the training data until it predicts the right value or minimizes the error. So we are going to show it in an animation way in a short while. So we only require just one neuron also in the hidden layer to realize our linear regression task. W1 and W2 are the connecting weights. And the B, that is the bias. Do you remember? In the linear activation function, we have added a constant called bias. Yeah, that is given to the hidden layer right now. We will see why we need that bias in the next slide. Because finally, we need to get y is equal to mx plus c equation format. Right? The output of the hidden neuron can be obtained by multiplying the input IC into the W1 weight plus the bias. So that is going to be the output of the hidden neuron. So this output is going to be multiplied by the W2 weight to get the VT. Right? So the VT or the output of the neural network can be obtained by multiplying the output of the hidden neuron by connecting weights W2. Right? So the hidden neuron output is IC into W1 plus B into all into W2 is going to be the VT. When rearranged, the equation of the neural network takes the form of a straight line. Y is equal to mx plus c. Here you can see the m is equivalent to W1 in W2. C is equal to B into W2. That means this neural network can learn the relationship between the circuit current and the terminal voltage. Okay. Let's move a little bit detail. Take a look at the graph on the left. The blue dot shows the experimental data we collected. Horizontal axis is the circuit current, IC, and the vertical axis is the terminal voltage, VT. We use this data to train the neural network. We usually call them the training data. Actually, the IC is the input, the VT is the output. During the training process, the input IC will be given and the output will be produced. The produced output will be checked with the input VT and it calculates the error and change the weight again. So like that, until we find the final output correctly or the minimizes the loss function, it's going to keep on training by changing the weights. Right? So we want the neural network to learn the straight line or the linear relationship between the terminal voltage and the circuit current. The red color line is the straight line produced by the neural network over here, right? You can clearly see the learning process. Let me play that animation again. So the green color here shows the loss or the error. you can see when the epoch iteration, what is that new word, epoch or iteration? In AI literature, a training cycle. So one input goes and it produces an output. Like that, all the IC gone through that is called as one iteration. So like that, we do multiple iteration or epochs to do the training process until we finally minimize the error. So in AI literature, a training cycle is called an iteration or an epoch. You can also see the equation of the line and how it changes in the learning process over here, right? So with each iteration over here, you can see the error is reducing. When the error is reducing, the line moves closer to the dots. The red lines move very closer to the dots. So that means the AI is trying to predict better and better with iteration number. With the iteration numbers are going on, the AI produces less error. When the error is less, you can see the red color line start from here. With the training process, it moves and it tries to fit through the blue dots. So that means the AI is trying to learn the relationship step by step and trying to fit the curve through these blue dots. Okay. So initially, the neural network output has an error. So this error reduces or comes down when it learns better and better. That's shown in the Greek color graph, each step. So we will discuss this in the next slide. Let's try to understand the training and learning process now. In the table, we have the data collected from the experiment. You know the equation of the neural network also shown over here. Vt is equal to W1 into IC plus B whole into W2. Let us consider the first training data pair. IC is equal to 0, this one, where the Vt is equal to 9. Hence, substituted in the equation of the neural network, we get the output of the neural network as BW2 because IC is 0. So Vt is equal to W1 into IC. So the IC is 0 for the first pair. So only the B is available. So the Vt is going to be equal to B into W2. Therefore, the error is going to be the 9 is the actual output, desired output, and the BW2 is the produced output by the neural network at the first set. So 9 minus BW2 is the error. We go to the second point where the IC is equal to 1 and the Vt is equal to 8.7. When substituted in the equation of the neural network, we get the output of the neural network as W1 into W2 plus B into W2, right? So the error here going to be is 8.7 minus W1 W2 plus BW2. So this is the desired output 8.7, but the neural network produced output is going to be W1 W2 plus B into W2. All right. Then we are going to go to the third point where the data is IC is equal to 2. The desired output is 8.6, the actual thing through the experiment. So once you substituted it in the equation, we are going to get IC is equal to 2 now. So 2 into W1 W2 plus B into W2. So now this is the neural network output. Our desired output is 8.6. So the 8.6 minus the neural network output is the error. Similarly, if you go for the third thing, so if you substitute IC is equal to 8, the last one. Similarly, you can calculate the error for all the other values, 4, 5, 6, 7. So I'm going to do the last one. So if you substitute the 8 IC and the desired output should be 7.4, but the neural network output is 8W1 W2 plus BW2. So the error is going to be given by desired output 7.4 and the neural network produced output this one, right? So that's how the individual training data error is calculated. As a summary, we have done for the first data pair, second data pair, third data pair, and up to the last data pair. So the total error or the error function for one iteration is defined as. One iteration means you send all the points one time and predict the output with the single weight, right? Then take the error, individual error, and square and add those errors. So that is known as the error function. Now, one iteration is done. Then you see the error value is really high. Then what you do, you change the weights randomly, or there are certain algorithms. We will see those things in upcoming lectures. So you change the weights and you again put the same inputs and try to produce the output and calculate the error function individually, add them together by squaring them. So now the first error is 9 minus BW2. Here 9 minus BW2 squared. The second error 8.7 minus W1 into W2 plus BW2 squared. So like that, you are going to keep on adding all the errors by squaring them. So this is the error function. So while the neural network is training, it tries to reduce these error function. So once the error function comes to a certain value point, it stops the training process, or it comes to a correct value. Then we stop the training process. So how this error value can be reduced? Here only changing component is W1 and W2, right? And the B, maybe the value of B. So there are three components are changing. Input doesn't change, output doesn't change, the neural network architecture is fixed. Only parameters changing are B, W1, W2, and B. Remember the synapses now in the biological neuron. When you try to learn something, it's try to adjust the weight or try to reduce the weight to make the memory strong in your brain neurons. The same thing happening in the mathematical neural network as well. By adjusting the weights, we are trying to produce the output, do that. Okay. So now we have the neural network output error related to the first training data pair, second training data pair, and up to the 8th training data pair. So the total error function is given by this. So the total error function is defined as this equation. So this total error can be minimized by adapting the connecting weights and bias. This is exactly what happens in the training and learning process of the neural network. In summary, output of a neural network depends on its connecting weights. Hence, the accuracy and the error of the output depends on the weights. In the training process, the neural network adapts its weights to learn to produce accurate outputs. Let's try to understand the weights adaptation process. So there is an example. So we were given the number of iteration, first iteration, 20th iteration, and 40th iteration, and the corresponding weights values and the bias values. If you substitute these values in this equation, you will be able to calculate the error. But I will just run over this example. You can try it in home and calculate the error. You will be noticing the error is getting reduced when the iteration numbers goes high. So when you train, the weight are getting adapted. So it try to predict the value much more accurately, right? So you can try this at home. So once you have done it, you can find the equation, that practical problem that we have trying to solve. So that is the finding the internal impedance of the battery using the experimental data. We got the assistance of AI to find the best fit curve straight line for the data where the VT is given as minus 0.21 into IC plus 8.8. And the circuit equation is VT is equal to minus R into IC plus E So therefore, by comparing the two equations, we can directly say R is going to be equal to the internal resistance is 0.21. But here you have to notice one more thing. If you manually calculate using those data values, trying to fit a curve through that points, definitely the answer will be different, because we stopped the training process at a certain point. We thought, okay, that accuracy is more than enough for us. But if you train more and more, it will try to improve the results. After a certain time, it will not improve. So that means at that point, you can stop and check. The answer might be very close to the actual answer. Okay. So that's how the training process happens in the neural network. Finally, we have determined the battery internal impedance or the battery internal resistance. So as we just witnessed, simpler problems such as finding the internal resistance of a battery using circuit current and the battery terminal voltage may be solved using a simple neural network having a single neuron in the input, single neuron in the output, and one hidden neuron. That is enough. But what we see on the screen are handwritten number characters. Artificial intelligence can be trained to successfully recognize handwritten characters. So if you write a number, take an image, put it into the neural network, we want to say, okay, the neural network need to predict what is this number. Yeah, we can do those stuff. Don't worry. That is the last lectures that we are going to do in this test run. So you will be able to build your own neural networks to detect and characterize the handwritten characters. So in week 5 of this program, you will in detail learn and test handwritten character recognition using single neural network as well as using the deep neural and deep learning. Okay. So here, unlike the simple problem that we have looked at, try to predict the best fit line. Here, we are going to have 784 input neurons and 3-4 hidden layers and 10 output layers. It's because it's a much complex problem, right? So you have to recognize the handwritten characters. So that is a little complex problem to identify the straight fit line. So you have 784 input neurons, 3 different layers, hidden layers, and 1 output layer with 10 neurons. So that kind of neural network we have to build in order to detect those characters in an accurate manner. All right. So with that, I would like to conclude today's lecture session. And if you have any questions, I'm happy to answer. That is a question. Dr. Logi, appreciate if you could provide a quick summary on what is the bias and what is the key importance of the neural training learning. All right, that's a good question. Thank you for that question, Jude. So let me come back to that point. Okay. All right. Again, I'm going to this slide. Right. Okay. Because if the neural network need to produce the output as a straight line, it should matches the characteristic of a straight line, right? It's a linear curve. So the linear curve is characterized by y is equal to mx plus c. Now, if you remove this b, let's say there is no bias. There is no bias, right? There is no bias added. What is the output Vt? Vt is just going to be IC into W1. Imagine there is no bias over here. IC into W1 into W2 is going to be equal to Vt. So that means this B is no longer there. Vt is equal to W1 into W2 into IC. Is that a linear curve equation? No. So in that case, can this neural network can predict the neural line? No way, because it's not at all close to the linear network. But by adding a bias to this neuron, we brought that equation. Vt is equal to mx plus c, right? Y is equal to mx plus c equation style. For that purposes, in certain neurons, the biases are added, right? So the biases are added on purpose to make the learning process in such a way for the particular application. Did I answer your question? I hope there are a couple of questions you have asked. One is about this bias. Did I answer the question regarding the bias? Is it clear, Jude? Okay, thank you. And what is key importance of neural training and learning? Yes, because once you are training the neural network, go to the next slide. I will go to the next slide. Give me a second. Yeah, here you can see when you are training, the error is getting reduced. When the error getting reduced, the red straight line try to fit through the points. So it started from somewhere here. When the error is reducing, it's trying to approach the line very closer to the dots, the blue color dots. So that means with the training only, you are making the weights adaptation, right? Because you have an input, you want an output, but you know what the output should be because it's a supervised training process. So in that case, with the training, you get the output, compare the error with the actual output, calculate and summarize, add all those errors by squaring it up, calculate the total error and see, oh my God, this is really big. So these predictions are really bad. So I need to reduce that lot function. Come back again, put the input, changes the weight. The weight will be changes randomly. So there are certain mechanisms we will discuss on the week 5. So weight adaptation mechanism. So then the weight will be changed and the output will be guessed. So now sometimes the predictions, earlier it predicted 5 for 9. Now it can predict, instead of 9, it might predict 7. But the error is reduced. So like that, each iteration, we need to go until we come to a desired value of error. So that means when the error is less, we say, okay, fine, that is enough for me. So I will stop the training process, right? So sometimes you can keep on training after a certain time, the loss curve will be flattened up. So after that, there will be not much change in the line. The line will stop at a point at the time. So we have stopped at, I think, 100 iteration or 80 iterations because to show you the training process, but it can be trained much more times than, or more than 80 iterations also. Then it will be more closer to each other, each points. So that's why the training of the neural network is really important to get the desired output by reducing the loss or error function. Okay, is that clear? Did I answer your question? All right, you're welcome.
Dr. Logie, I think it is now 9:20. So we'll have 1 or 2 questions and then wind off the session today. And tomorrow again, we will be meeting at 7:30 in the evening UAE time. Well, I have a question just to understand. Any AI solution, do we need to have a training of the model?
Yes. So AI means you have to train. AI means deep learning I'm talking about. So you have to train that model for the weight adaptation. For individual points, for particular application. For example, let's say you are going to create an AI to predict the next day weather detail. So how much the intensity of the sun, how much is the temperature, whether it's going to rain or not. So for that particular AI, you have to train that network based on the previous historical data. So for any application, you have to do the training. But you might ask, there might some neural networks, you just ask the question, the ChatGPT, but it produces an answer. But those are already trained. Those are already trained. They are like billions of neurons are interconnected. So those are already trained. So it's capable of answering your question. So the trained neural network should be trained to produce accurate output. So the training process makes a huge difference. Actually, you can see the difference. There is a Bard by Google and there is ChatGPT by OpenAI, but both the AI are following the same kind of transformer approach, but Bard is not that good comparatively to OpenAI. Why? Because the way that they have trained, the way that they have structured the input data are completely different. The OpenAI acted smartly to do that part. So therefore, their ChatGPT outputs are really good compared to the Bard outputs, right? So Bard also do a better job, but their training is not good as the OpenAI. So it depends, right? So you can clearly see I'm taking these examples because everyone have tried those two transformer models. That's the reason. Did I answer your question, Para?
Yeah.
All right.
Any other questions, gentlemen? If you have any questions, please feel free to ask. Since we have reached now, it is 9:20 UAE time. If you do not have questions, so we will meet again at 7:30 UAE time, 7:30 in the evening tomorrow. And again, I know that even for me, it is a bit hard to understand if you're not coming from AI background or probably in ICT background, you might not be able to understand things easily. But so I presume that Dr. Logi, these are the basics that need to understand how AI works. So if you have any questions, you can reach Dr. Logi now. Anyway, you will be having the access to the portal, so training platform, so you can try that, and then you can come up with the questions you have and ask from Dr. Logi and the rest of the resource persons. If you have any further questions, please ask. I think one more question we can take, and then we will close the session for today. So silence is that seems to be no more questions. So shall we wind off, Dr. Logi?
Yeah, good.
All right. Okay, thank you very much for joining today. And please feel free to give your feedback. And tomorrow, 7:30 in the evening, UAE time, we'll meet again. Thank you and good night.
Hey, good night. Bye-bye.
Thank you, Parag. Thank you, Dr.
Good night,
Logi.
doctor. Thank you.